So we're here to tell you about a fictitious startup from the future. You may be wondering about the watermark on the slide. Yes, that is indeed an R wall. And any good startup knows that you need a logo that points up and to the right to represent growth. Without exception. One example is Flash. Be done with Flash. Don't use it, period. JSON-P is a horrible hack and it needs to go away and has been solved by cores. JSON-P is definitely one of those things that I think the awareness, especially around cross-site scripting, even with content security policy, is something that needs to be addressed. Inline JavaScript. It's ugly, it's hard to manage, and it makes applying content security policy very difficult. Now, Content Security Policy 2 came with mechanisms for whitelisting inline JavaScript, particularly the nonce and hash features. Particularly the nonce and hash, doesn't sound any better. So I was never a fan of content security policy nonces because it still allows dynamic JavaScript, so you still have the potential for a bug. It's best to remove it or secondarily use content security policy hashes. Do not allow the use of eval, whether on the front end or the back end. You can sort of think as using eval as code that's never been reviewed, which to my previous point is not allowed. Eval is not faster than JSON parse, and even if it is, I don't care. It's inherently dangerous and it needs to go away. And again, do not have dynamic JavaScript. Everything I've just mentioned in this previous slide is detectable by a regular expression. No static analysis is needed. and a bot can catch it. Lastly, always stay current. This is your frameworks, your libraries, your languages. If you get behind, you're gonna get stuck, period. I would actually say this is the hardest thing to accomplish of everything I've mentioned. I've only actually seen it happen at one company of about 15 engineers. They actually lived on master, not even just release versions. We also had maybe 500 users, which made it a little easier. Getting stuck on older versions of libraries means you cannot leverage the benefits of the new libraries, features, patched APIs. The scarier thing is you might have engineers joining your company who have used newer versions of the patched APIs and make assumptions that they're safe when they might not be. A lot of the security being built into frameworks these days, you can't take advantage of without significant backporting. I think one example of this is Ruby on Rails uses a tool called Sprockets to package all of its assets. Now, if you sort of use this automated system to package your assets together, it's really easy to make a configuration change and you get sub-resource integrity for free. Being able to do sub-resource integrity without writing a single line of code is incredibly powerful. Unsupported code greatly increases the chance that you, the security engineer, will get stuck backporting the patch. Ruby on Rails just recently got support for per-action CSRF tokens, such that if a CSRF token is leaked, it can only do that one thing. If you get delete repo X, you cannot delete repo Y with that same token. While this is sort of seen as potentially unnecessary, this is the belt and suspenders thing. And to take advantage of that, GitHub had to do significant backports. Not only did the code and the interface change, but the internals had changed too. It was incredibly difficult to do.
On that point, I get if you're really far behind, it could be a problem to switch. But the double-edged sword there is there's an assumption that newer code is secure. And somebody could push a library, haven't fully vetted it, and now you've introduced a security flaw because not everybody else subscribes to the same strictness. And so being right on the bleeding edge feels like kind of going over the cusp there.
I absolutely agree. That is 100% valid. But in my experience, that's not the case. Getting stuck is still worse. Well, as a whole, I would say. Do you agree with that?
No, I think that if you get stuck 2, 3, 4 versions back, you can't move.
Right.
So I get that. I think it's a balancing act, and I just as a quick counterpoint to bleeding edge.
Absolutely, it's absolutely valid point. Newer code is not always better. In theory, it is because people have sort of learned lessons. For example, introducing a timing attack at this point in development is a lot more difficult than it was 5 years ago, where the framework might be stuck. Twitter had this problem. They decided to switch frameworks entirely. GitHub is starting to experience this problem, and it's starting to cause a lot of problems. So don't be stuck. So everything in the previous slides just means to enforce that security does not have time to find or fix bugs. It only has time to prevent them. Sure, if you have a massive army of engineers and a massive army of maybe consultants, that's different. But we're talking about scaling a small team of individuals. Design was secure by default in mind. This has to be behind everything you do. Make security an opt-out decision instead of having to opt into security. It's incredibly powerful. The default effect is a psychological thing that is amazing. Make opting out of security a very conscious decision. Name your function something super crazy like bypass all authorization because I know this is safe. The person typing out those words has already had to think about what they're doing. The person reviewing the code is definitely going to think about what they're doing because they might have context. And a bot can definitely detect a string as simple as that. But understand that you're only going to have moderate adoption at this point. Again, this is sort of seen as like tinfoil hat-y, like it's hard to sort of impress the benefits upon everyone. So just be realistic there. Sort of going back to the secure by default thing, during the Rails 2.3 transition, and Rails 2 values were not automatically HTML escaped, and it was a manual transition. A lot of people had sort of moved to Rails 3 and sort of taken this for granted when they develop on Rails 2 apps. And a lot of people would even say, why do I have to escape a number? Why do I have to escape a constant? Numbers can become strings, constants can become dynamic, and like I said, everything has to be HTML escaped or else you're going to run into a problem. I'd rather solve the problem entirely than by piecemeal. Roll out all the security headers. Anyone who knows me knows this might be my favorite part of security because the browser vendors and the W3C and everyone involved has done tremendous work over the past 5 years to make the browsers actually safe to use and to make the websites these browsers render much, much better. That's a whole talk on its own, and I'm sure it's going to be brought up many times at this conference. Do your best to support fewer browsers. I love that GitHub only cares about current users of Chrome. That is about 80% of our user base, and I made that number up, but I can tell you it's the vast majority of users. Sure, we do care about everyone else, but if you're on IE6, get out of our website. We're not going to support you, period. And some people still have to support IE6, or these crazy feature phones from across the seas that just have zero security whatsoever. We are lucky that our users are typically very technical and keep their stuff updated. Launch a bug bounty. I don't think there's any debate about whether or not bug bounties are great. They are. They basically can show you all the things that you hadn't thought about. And it's really, really good when you get a series of reports and something that you thought maybe was secure, or maybe you didn't even know about, and now someone else has told you a problem in your organization. These patterns can be used to fix more things in the future that maybe haven't been discovered, because these are your blind spots. And a colleague of mine used to say, and I can't get this quote out of my head, the best indicator of the next bug is the last bug.
How do you think of the workload trade-off for simultaneous sharing up in the public bug bounty? Working people on positives and triage
Use
issues
triage services. Throw money at the problem. So I was fortunate enough to where every bug bounty I participated in started when we felt comfortable starting it. There's a lot of people who will say, don't start a bug bounty just because you should have a bug bounty, because that could be disastrous with United. Be careful is all I can say. Be purposeful in what you do. And don't lie to yourself about maturity. So the last big bullet point of this huge slide is you got to integrate static analysis into your workflow when you can. I want to tell a story about a project that happened at Twitter a bunch of years ago that gained some popularity, known as SADB, the Static Analysis Dashboard. The concept behind SADB was a developer will push code, will run static analysis, we diff it from the diff point, so we only show the new vulnerabilities, and we send the developer an email saying, hey, we noticed these new findings. They had the option to go in and call bullshit on us, which I think only happened a few times. I don't think people were comfortable with the word bullshit. After you would fix the vulnerability, you get another email saying it's been fixed. The reason you only show the diff is because you cannot expect anybody, including a security engineer, to review an entire report at all times. The human brain, when it has too much information to process, can only process changes, and that's exactly what's going on here. And I want to talk about another project at GitHub named Sentinel. Sentinel is sort of designed after SADB, but in a very specific way to GitHub. Same deal, you create a pull request, Sentinel runs, any new vulnerabilities will add line comments to the individual thing in the pull request, super helpful. Again, these are only warnings that we have very, very high confidence on. Cannot spam people here. Now, after the code is merged, a second scan is run. Every bell and whistle turned on, all the false positives galore. But the thing is, the only consumer of this is the AppSec engineer who's on the call that day, because we can much more quickly glance at what's going on and decide whether further investigation is needed or not.
So what have we accomplished so far? We've instantly scaled the security team via the bug bounty program. So now we have some assurance that code has been checked for security defects by both humans and robots. So in theory, our product should accrue less technical debt. Through our content security policy, we have some control over what third-party integrations are added, or at the very least, more thought and discussion need to take place before they're added. We have a plan for triaging and remediating issues through experience with the bug bounty program. We also have faith that we don't need to re-architect our app for security reasons for a very long time. We've also eliminated or limited many classes of bugs right off the bat using header and cookie settings. So we've limited cross-site scripting via our content security policy. Our script source directive is pretty much as strict as possible for the specification. We've set object source to none to disable the use of Flash and Java. We've enabled sub-resource integrity, which ensures that sources from our content delivery network match pre-computed integrity values. So if our CDN gets compromised and starts trying to serve malicious code, the browser will realize it is incorrect and won't run it. We've eliminated browser traffic sniffing over plain text. We're on the HSTS preload list, so that means that HTTPS is baked into the browser for our website. We've limited browser HTTPS man-in-the-middle attacks using public key pinning. We've disabled any means of cookie theft using the HTTP only and secure cookie flags. We've limited data exfiltration via the DOM using our content security policy. And lastly, we've limited referrer leakage using the meta tag. So don't underestimate the importance of building a happy, healthy culture. We want to establish a bones are just bugs culture. It should be triaged, prioritized, and tested just like any other bug. These security bugs shouldn't be grounds for shaming. We don't want to punish the person who wrote the vulnerable code to do any investigating or pressure them to fix the issue. This person's already under enough stress. After all, everyone has written vulnerable code in the real world. But however, when analyzing the bug, we should still ask questions such as, can we delete this code? Does the framework need hardening? Is there a pattern of mistakes that we can account for? Is this actually security by default? How can we detect this earlier? And lastly, how can we socialize this issue to bring awareness? You also shouldn't be thinking in terms of us or them. It should always be a we. Security should take the initiative to join meetings or maybe provide some engineering support for non-security related projects. And security should always congratulate people on shipping code. Security, for a team that's involved in almost every project, we don't congratulate people nearly enough. You don't want to fall into this mindset that every new project is just going to make your life more difficult. You want to treat it as something that's good for everyone, unless it's just truly terrible. You also want to be visible and let the company know what you're planning at all times. And ultimately, the goal here is to be someone that people want to include and not circumvent. And at this point, PubPub has their first cultural win. The engineering team implements two-factor authentication with a little help from security. So just because a feature is related to the word security doesn't mean that only the security team needs to implement it. The security team might have a better idea of sort of the pitfalls of certain choices, and so we'll provide guidance, and then we will also be the ones to So when it comes to culture, really the overarching theme of your culture should be that security is not here to say no, we're here to say be careful. So at this point, PubPub hits its first milestone. The company is referred to as a unicorn, and they're growing faster than they can manage. And at this point, it's time to hire an actual security team. Those two contractors I mentioned earlier help manage the transition and possibly stay on as advisors or join the team full time. The team plans splitting into security ops and application security. AppSec becomes its own entity, and now roles are more clearly defined, and now when someone has an issue, people outside the security org have a better sense of who they should go to for certain issues. So now what have we accomplished? So at this point, engineering and security are best pals. Security becomes a good customer and provider. The communication couldn't be better, and now we're all set up to grow.
But of course, as you grow, you're going to experience growing pains. Culture will fail, quality will drop, bugs will surface. It's important to illustrate the fading quality as a culture problem, and all of a sudden it's really hard to argue against it. People don't fail, processes do. Bad processes are a result of a fading culture. Fading culture can be addressed with better processes. At this point, unfortunately, conversations with security are not happening as frequently as you would like. This does not mean the exclusion is intentional. Very often, the sort of perceived tribal knowledge amongst the team can sort of give confidence that they can make a good risk assessment, which unfortunately might differ greatly from what the AppSec team thinks. Also, as you start to grow, native code will enter your stack no matter what you do. I don't know anything about native code security, and neither does anybody on our team. So we just outsource the shit out of that work. What's going to also happen is you're going to have an incident. This is a picture of the TweetDeck incident from a few years ago that Jim memorialized as the scariest Halloween costume ever. Incidents are unfortunate, but they're not always bad things, and good things always come out of incidents. I want to give one example, and I also need Jim to fact check me here. The TweetDeck incident, the first thing everyone said was, why didn't this have content security policy? This would have killed this bug entirely. Well, unfortunately, the talks with the TweetDeck team sort of stalled out. We had a botched deploy, and sort of was put on the back burner while we were focusing on more important things. If I recall correctly, the CSP project restarted immediately, and it was implemented within a reasonable amount of time. All right, good. I don't trust my memory sometimes, so it's good to have you here. For every incident, create an issue that people can follow along with, have a chat room perhaps dedicated to a specific incident itself, open up a video conference. Do not pile on an assistance if you cannot actually help. Stay out of people's way, but follow along if you can. During the investigation, again, do not point fingers. I want to talk about a recent incident at GitHub which caused a private repository data to get sent to other people who hadn't even requested it. If you look at the pull request that caused this bug and you say you saw it coming, I'll say you're a freaking liar. First of all, the person writing the code has more understanding than anybody else about that specific part of the framework than anybody in the world. They did not see it coming. The people reviewing the code, lots of people were like, yeah, this is great, good idea. It was deployed to our Canary server and no problem was detected. As soon as it went to production, more exceptions than we've ever seen in our entire life at GitHub happened in a matter of a minute, and immediately we rolled it back. What happened? What was the problem? The Canary process did not detect this. It should have. And we did a lot of investigation to figure out why it did not. For every incident, fix the problem, diagnose the impact, notify those affected, and make a public statement. People really appreciate transparency. No company is perfect. Everyone's going to make mistakes. Deal with it in a positive manner.
So now what have we accomplished? We've been through our first incident, and we now know where the gaps in our planning are. Through the post-mortem, process failures were identified and remedied. The company had a rude awakening, and now interest in securing all the things is at an all-time high. But throughout this whole process, we've been very sensitive not to enact security feeder. Engineers sympathetic to the AppSec cause push for change. Many of them make direct contributions during this push for catching up to their technical debt. So finally, the security team grows up, and now day-to-day tasks are well-defined. We've crossed what we'll call the year of content security policy, and now all our internal and external apps have a CSP. Other critical security roles, such as the incident response team, government risk management compliance, network engineering, they're all doing their thing.
So we've reached a new level of maturity within the security program. We're no longer fighting fires, we're fixing classes of problems. At this point, framework hardening becomes a day-to-day task that gives huge returns. Like we mentioned earlier, since we chose Mustache, our code and data have been officially separated by some definition of official. In this sort of mythical world, we've also made it so that the browsers cannot make HTML via string concatenation. The amount of string concatenation to build HTML and the amount of XSS ratio is 1-to-1. We've also made it so that interpolated or SQL with interpolated user input would not run. These things do not exist today, but they should. I've heard PL SQL is pretty good at separating code and data, but I don't know enough about it. You also get to work with the standards bodies to help shape specifications that might benefit you and aren't sort of available today. And I just want to go over a couple examples, so just bear with me while I ramble for a little bit, if I haven't already been rambling. When GitHub implemented sub-resource integrity, we thought we were done until we got a boundary report about a script that did not have an integrity attribute. In our minds, we want it on everything. Why doesn't the browser say, if you use sub-resource integrity, have a mode so that you require sub-resource integrity for everything? So I don't recall if we proposed it or we pushed for it or whatever, but it eventually happened, and I believe it's going to be in browsers without flags soon. Another example that happened a lot more quickly was the origin when cross-origin referrer policy. GitHub takes leaking the existence of a private repository very seriously. It's a problem we'll never solve, but it's a thing we're sort of still plugging holes with. If you had a link in your README doc and you click a link and it went to an external host, you've now leaked the existence of that referrer to the external host. It's not good. I can't remember the exact options at the time, but we tried to implement the origin policy such that for all cases, the only value for a referrer would be github.com, https github.com. Unfortunately, that breaks a very important feature of Ruby on Rails known as redirect to back, which, as you might guess, uses the referrer to redirect you to where you were. So we couldn't use that. But we thought it's okay to leak a referrer between GitHub and GitHub. It's not okay to leak a referrer from GitHub and someone else. So that's where origin and cross-origin came from, and it does exactly that. And we implemented it, and it was a great success. Another example from the Twitter days was the content security policy hash feature. Like I said, I do not like nonces for their inherent dangerousness, but trying to use a nonce in a high traffic website can be very expensive. We had a bit of inline JavaScript that was in a fragment of HTML that was cached because it would be on a given page hundreds of times, and we didn't want to regenerate it every time. You could not get rid of that inline JavaScript, I think for political reasons, I cannot remember. And a nonce does not work if the fragment is cached, because then the nonce is cached, and it's not a nonce, and it will never match what's in your header by definition. So we thought, well, this bit of JavaScript never changes. It's the same every single time it's used. We can compute the hash of that JavaScript. Can we tell CSP to only run scripts if it matches that hash? That's exactly what happened. This, unfortunately, I think delayed content security policy level 2 for a little while. And unfortunately, by the time it was ready, we had moved away from caching that fragment. But I still think it's good. Something I'm really pushing for now is what's called hashes for external sources. Very similar to sub-resource integrity, where you sort of know the value of your content ahead of time and you can compute the hash at deploy time. Why can't you just specify the hash of those external sources inside of your content security policy? So currently, I think the best thing that you can do that's sort of widely supported is to move all your assets onto one CDN, and your script source becomes that CDN, and you're done with it. I think the holy grail is the list of every single script you source and the hash of it, because you never know. There might be a file lying around on your CDN that you don't know about. You have a content injection bug that pulls down an old, outdated version of the library, and you now have XSS when you, in theory, had the best content security policy you could have. So at this level of maturity, AppSec is integrated into every part of the workflow. We're doing architecture reviews, we're doing code reviews, there's peer reviews, there's automated reviews. We're sort of releasing features to our bounty hunters sort of as an early release so that they can hack on things before things hit the general public. Another great thing at this point is that shared responsibility amongst the team is very, very clear. We want to optimize for engineering-focused time. Distractions are terrible, they ruin everything. Not everyone has to handle everything all the time. When I first joined GitHub, the bounty triage was on a first-come, first-served basis. Whoever had their inbox open when that report came in would handle it. This is bad for a number of reasons. For one, we're geographically distributed. I used to get up pretty late, and everyone was in a time zone in the future, so I didn't do any bounty triage. Everything was already handled by the time I was ready to work. And that's not fair. But more importantly, what would happen is we're always stepping on each other's toes. You guys know, okay? And we'd have responses that would come back to the reporter, like within seconds of each other from two different people who might say two different things. That's not good. The other benefit of defining this role and separating things is like when it's not my bounty triage day, I don't check my email, period. That level of focus is amazing. This requires that you trust your peers to sort of act on your, without you. If I'm not looking at my peers' response to a bounty triage and they misspeak, that's actually okay. And it's a lot better than me analyzing every single thing they say. Do the work that you do best, whether it's your skills or your interests. The combination of two is obviously better. And don't do the work you loathe. If you don't enjoy doing the work you're doing, you're gonna do a bad job, or at least not the best job you could be doing. And the best part is, if you're just honest about what you like and you don't like, not everyone is like you. Perhaps something you don't like is something someone else loves. I hate black box testing. There's people on our team that like it. I don't do any more black box testing anymore. Another thing that sort of happened after a few years is that your bug bounty starts to dwindling returns. The number of reports coming in is much lower than it was. The quality of the reports is terrible, and you haven't had a serious vulnerability in like a year. GitHub decided to address this by launching our bug bounty promotion. We pay out for the months of January and February. The top 3 most severe reports will get a bonus on top of what they're already getting paid. And then just sort of the best report. Maybe it's not a serious vuln, but you gave us proof of concept, you gave us a fix, you gave us network traffic. These are the best reports that we get, and we want to encourage this. Now, again, I've already said that I'm a huge fan of bug bounties. I'm more of a fan of bug bounty promotions. Within the first day, we got a top payout vuln that would not have happened without it. I don't want to say the rest of what has happened so far because none of it is public, but all I can tell you is it's been an overwhelming success. And I'm very thankful for the GitHub engineering, or the GitHub org, because we got graphics designers on this, we got PR people on this, and we even got like sweet limited edition t-shirts that we're giving out to researchers. So the next phase in your startup's life is you're going to get ready for IPO. This is when things start to get a little nerve-wracking. The company is doubling in size year over year. Security team is growing at a slower pace. And the security role tends to get a little more compliancy. There's absolutely nothing wrong with doing compliance work. I've seen great things happen, but let's face it, we all hate it. Except for those wonderful people who can manage it. Having time to implement key strategies themselves, the company starts looking into acquisitions. I am not happy about this, but it is a necessary evil. Every acquisition, by definition, is going to ruin your culture. I highly doubt any company you acquire is going to just sort of fit right in without any resistance. So what can you do? You can come up with a diligence plan for incoming acquisitions, so at least you can get some idea of what's going to happen. Do they have a security team? Do they run a bug bounty? How do they store their passwords? Do they have an incident response program? How are credentials managed? Having this in place before the acquisition can be very useful. And if you can do a third-party assessment of these acquisitions beforehand, that's even better. But most importantly, you need to know, is this an acqui-hire or an actual acquisition? The acqui-hire means that you're just going to buy the company for the engineering talent. This is what you want because you want to shut down the product. You don't want to maintain it. What happens through acquisitions is that your development stack starts to diversify. All these technologies that you haven't blessed are now part of your stack. And then you go into a little corner and cry because everything you've built up has just been torn down overnight. But as a result, you can consolidate your development stack. And I think Twitter did a really good job here. As they were decomposing their monolithic application into services and as they were acquiring companies, there was a common platform to build upon that was blessed. The security team had a lot of involvement with this new web framework that was being built. First of all, we learned the lesson of Ruby on Rails, which does everything, which does some crazy things that no one would ever actually need to use. And I guarantee there are more demons in there. The framework they built did nothing but the most basic stuff we could possibly need. There were no bells and whistles at all. At this point, it was our last chance to really, really stick to the secure by default. We applied all the security headers by default with a very strict content security policy, and you had to opt out. And guess what? That monolithic app that we had trouble applying content security policy, we now have dozens of greenfield apps with maybe 1 or 2 pages. A default content security policy that works for all of those was really easy to come up with. Have a plan for automation. Twitter, had sort of been very happy with the way SADB had progressed, but we didn't have an answer for Scala. So instead, we focused on designing the APIs that were secure by default and would have to be opted out of, and then we just searched for those strings.
So finally, 12.book moved beyond basic application security and more into business logic. So now the AppSec team is implementing those specs designed earlier, and they're essentially acting as beta testers of the internet. We have unit tests for all authorization checks, and negative test cases are added. There are different rules are added for users because not everyone has the same account needs. Say billing managers, marketing, or PR don't need the full access that their employees might need. We've applied risk-based rights to user accounts. We introduced a read-only mode to those accounts suspected of being compromised. And higher profile accounts will receive extra scrutiny. We'll also do an automated analysis of user activity to expose patterns of abuse. We'll do log correlation and use machine learning to help classify activity. And then we'll have alerts and dashboards that the incident command people can look at to stay informed. It's important to understand how people are using your site or where they are focused. And then you combine that knowledge with the risk analysis, and then you'll know where you need to prioritize your efforts. And lastly, at this point, account recovery mechanism for secure and usable. So finally, the IPO happens, and the application security engineer loses interest and heads to the next startup.
I just want to point out some further resources that I think are useful. Ryan Geehan, Magoo did a great series on starting up security. This is still an active blog. I encourage everyone to read it, whether or not you're in a startup or in an enterprise situation. Another thing that I've started working with someone on is the CTO security checklist. I know how we feel about checklists. They're not great. But I think this one is really off to a good start, and I hope to incorporate everything I've talked about into that later. And very lastly, I'd like to promote a conference that I'm putting on in April of 2018 out in Hawaii. I think it's going to be a great event, but I might be a little bit biased. So if you'd like to learn more, don't go to our website yet. It doesn't work. I meant to. Well, we have a Twitter handle, so you can go there. And that's it. So, questions?
So,
We should do this right.
so the challenge I see a lot of times with startups is they don't even have enough manpower to do code review. So what do I do?
Automate as much as you possibly can, except that you can't fix everything. I really try to emphasize a lot that humans aren't doing a lot of the code review itself, but you can never cover everything.
So how do you reconcile that with those early startups that are following an agile project management style and they're rushing to put out an MVP? And how do you convince them to do all that?
So an agile shop that is capable of rushing and pushing things out is also capable of pushing out security fixes just as fast. I think that the agile workflows and this move fast break thing is exactly the way it should be. You're not going to catch everything, and if a bug is out on the internet for a little while and doesn't get exploited, it's not a bad thing. Only exploited bugs are bad, and yes, we cannot know if every bug has been exploited. But being cautious and stopping the company will ruin the relationship with engineering, and embracing that culture and leveraging it just is amazing. I can deploy a fix in GitHub as long as I get that approval in a matter of minutes, and it's just a chat ops command. Everyone in the company can do that too. If everyone can deploy and fix something, everyone can make it more secure too. Is that?
Yeah, I agree.
Okay.
Do you recommend React as a secure framework?
I have zero opinion. I've never used it.
Yes, I do.
You use it?
Yeah, React's great, and it has the grep base. It has the huge advantage of being greppable for insecure defaults. Just grep for the word dangerous and.
So I trust his opinion, so now I have an opinion.
That's fine.
That's time? All right, if you guys have more questions, we'll be outside.